Okay, so for week 4, we're going to take a look at arithmetic sequences. You can say arithmetic or arithmetic, either way. And basically the idea is we're looking at lists of numbers, trying to find a pattern, and predict the next number in the list. Okay. So, first of all, what is a sequence? Okay, a sequence is a list of numbers that's in a certain order. They can't be random. There has to be a pattern for how you're getting one number to the next. Okay, so there has to be a pattern. Each number is called a term. Let me fix that. Each of the numbers is called a term. That wasn't really written with proper English. So each of the numbers is called a term. So if you had a sequence like this, this would be the first term, second term, third term, fourth term, fifth term, and so on. So for an arithmetic sequence, you can get any term by adding or subtracting the same number repeatedly. Right? So maybe the pattern is +2. You add 2 each time. Or the pattern could be something like -3. That you -3 each time. But the pattern has to be adding or subtracting. It can't be anything else. It can't be like, oh, doubling each time. Nope, not for this kind of pattern. Okay. What you add or subtract, well, it sounds a little weird, but it's called the common difference. Okay, that's what you add or subtract each time. Yeah, can you please read the following? Thank you. So here's an example of an arithmetic sequence. 10, 13, 16, 19, 22. Does anybody see what it is that you're adding each time? Yeah.
10 plus 3 is 13.
Right, you're adding.
16.
Yep, you're adding 3 each time. So on the line that says the common difference is, you want to put 3. Let's say you couldn't figure out that it was 3. Okay, so if you had trouble, I don't know, you couldn't figure it out. Let's take 22, take this one, and subtract the one that came before it, 19. What's 22 take away 19? 3. Or let's do a different one. Let's take 16 and subtract the one that comes immediately before it, 13. What's 16 minus 13? 3. That's why it's called a common difference. Because if you take any term and subtract the one that comes immediately before it, you will always get the same number. In this case, it's a 3. Okay. So any question on that pattern of adding 3 each time? Yeah, can you just wait for one person to come back? Okay. Yeah, as soon as one person comes back. All right, let's look at this one. Okay, common difference. That's. Anybody think they see what the common difference is in this one? Yeah. Let's check it. How do you get from here to here? Yeah, you -5. Let's make sure it's the same again. -5. Yep. Again, if you were stuck and you couldn't figure out the common difference, take any number you want and subtract the one that comes before it. What do you get if you do 120 minus 125? You get -5. Yep. That's how you can always figure out the common difference if you don't see it. The diagram right there, they show you the same thing, -5 each time. Okay, let's try this one. Type well, we're not typing, we're just handwriting, the missing numbers in the sequence. Okay, so to figure this one out, what we want to do is look at the middle part, and we have enough there we can start to figure out the pattern. How do you get from -41 to -45? And remember, the pattern has to be adding or subtracting. Yep.
Add 4.
You add 4. Let's try it. Let's take our calculator. Let's take negative 41. And you said add 4?
Subtract.
Okay, that gave me negative 37.
Like subtracting 4.
Yeah, so let's try it that way. Okay, let's try subtracting 4. Okay, subtract 4, and we get negative 45. Okay, so we minus 4. Let's make sure that pattern continues. How do you get from negative 45 to negative 49? Yeah, subtract 4. And Caleb, how do you get from negative 49 to negative 53? Yeah, very good. You're going to subtract 4 again. So the pattern is, as you go to the right, you're subtracting 4 each time. So what would you get if you do negative 53 and then subtract 4? What would that give you? Yeah.
Negative 57.
Yep, that would give you negative 57. Perfect. So that's what goes in this box. Now, how are we going to work backwards to go the other way? I got to get that first one somehow. Nathan? Well, if we subtract, that's going to keep bringing me this way.
Oh, my bad.
We got to go back the other way one time.
So it would be negative 30.
So what would be the reverse of this? So you're subtracting 4 when you go to the right. What do you think you're going to do when you go back to the left?
You're adding.
You're going to add 4. Yeah. So to go, I'm going to do this in a different color because this one's different. We're going the wrong way. We're going back to the left. What's negative 41 plus 4 going to give me?
Negative 30.
Negative how much?
38.
I think that would be plus 3. Yep.
Negative 37.
Yeah, perfect. Negative 37. Okay. So generally, we always go to the right. But they did do one that was backwards here, and they made us go to the left. All right, let's try this one. Okay, we got enough terms in the middle that we can start to figure out what the pattern is. How do you get from 68 to 61? Yep.
Subtract 7.
Yeah, you subtract 7. You got to make sure it's the same for all of them, though. How do you get from 61 to 54? Yeah? Yeah, use 3 for 1 versus another. How do we get from 61 to 54? Logan, you see how we get there?
7.
Add or subtract?
Add.
So let's see, what's 61 plus 7? Does that give me 54?
No, subtract.
Subtract, yeah, we're going to subtract 7. And how do you get from 54 to 47?
Subtract 7.
Yep, you subtract 7. So the pattern here is you go to the right, you're subtracting 7. So what would be the number in the last box? Oh, Carrie, you see what the number would be in the last box?
Oh, I already know that one. Which one am I looking at?
So
Or to the last.
the last box.
Oh, it's 40.
Yeah, you minus 7, you get 40. Okay. Now they have one where they want us to go backwards. What's going to be the pattern to go backwards?
-7.
So negative 7 brings us
Plus
this way. Yeah, we got to reverse it and do plus 7. And 68 plus 7, yeah.
75.
75, perfect. Now, let's say I wanted, okay, this is called the first term, second, third, fourth, fifth, sixth. Those are the terms. Let's say I wanted you to tell me the 957th. What do you think about that? If I asked you for the 957th term, what would go in that box?
957.
Yeah, I want to know the 957th term. What do you think? Is that going to take a while? No?
You do the right equation.
Right. If you find the pattern and you write the right equation, you don't have to keep subtracting 7, 900 something times. That's going to take forever that way. Okay? So the last thing we're going to look at is how you can find a formula that will give you that automatically without minusing 7 900 more times. Okay? So here's our pattern. Okay, and you guys already have this on your notes. A couple things that you have to fill in. I'm going to circle them. When you write down your answer, you need to fill in what I just circled in purple, and you need to fill in what I just circled in purple there. You do not have to fill in for the n. Yes?
Can you come out
Yeah, can you just wait until
Yeah.
All right. So A sub 1, that's how you read that, A sub 1. That is the first term in your pattern. So that's the first thing you got to know how to figure out. What's your first term? D is the common difference. Okay? That's what you're adding or subtracting each time as you move to the right. That's how you always have to think of it. It's what you're doing as you move to the right. N, you don't have to change that at all. N is going to stay the same. So if I wanted to know the 957th term in this pattern, N is the number of the term I want to know. So in that case, it would be 957. All right, so let's try an example and see if we can figure out a pattern. Okay, so they're asking you to write a formula for the following sequence. What is one thing that I definitely need to figure out here that I'm going to have to plug into my formula? Yep, I need the common difference. That's part of my formula. What am I doing? I'm adding 6. Yep. So when we write our formula, we're going to fill in a 6 for D. Okay, so actually I can put that down here because they give us some space. D is 6. And what's the other thing I have to identify? Yep. I need the first term. Yeah, the first term here is a 7. Yep. So now take these two numbers and we're going to substitute them into the formula. Micah, can you remind me, what's that formula that we're going to plug into again? So it starts off A sub n equals, yeah, okay.
Look at your packet.
Just cheating if you D.
So there is a D, that's part of it. We'll put that over there.
Equals A1.
So A sub n equals, yep, you said A1
Plus D.
plus D.
Parentheses N minus 1.
Yep. That's the formula you have to use anytime they ask for an explicit formula for the pattern this week. Okay. What are we going to fill in for this? 7. And what are we going to fill in for this? 6. Okay. So now you have a number on the outside of parentheses. Does anybody remember what property we have to use here when we do that? Yeah.
Distribute.
Yeah, perfect. We're going to distribute it. How would we write 6 times n? Yeah.
6N.
6n, good. And what about 6 times negative 1? Yeah,
Negative 6.
-6. And Miriam, when I combine my like terms, what's 7 minus 6? 1. So there is your pattern. So now, if you want to know the 12th term in this pattern, right? They want to know that one right there that I just put a box around. So the 12th term, you don't have to find every one of these. All we have to do is take the number 12 and plug it in right there for n, and it'll automatically tell me the 12th term. And I don't have to find all of them. So let's do that. So it's 6 times, and then fill in whatever term you want to know. Okay, they want 12 minus 1. Okay, 6 times 12 is going to give me how much? 72. And 72 minus 1? 7 minus 6. Oh, you're right. Thank you. Yep, 7 minus 6 is a plus 1. What's 72 plus 1? 73. Perfect. Yep, because 7 take away 6 is positive 1. Yep. So that's the term that would be right here. And we didn't have to figure out any of the other ones before. Any question on that? Let's try the last one. The last one says, write an expression to describe the sequence below. Use n to represent the position of a term. Okay. So, what are the, in that formula, what are the 2 things we have to figure out? Yeah?
How much we're increasing?
Okay, what letter do we call that one?
Is it D?
That's your D. And what's the other thing we have to figure out? We need the D and we need the A1. Yep. Okay, let's start with the D. What are we doing each time as we go from left to right? Adding 8. Yep, you might say, oh, it's times 2 to get 16, right? But it's not times 2 again to get 24. Right? It can't be times. That's not the pattern this week. It's got to be adding or subtracting. Okay, so we add 8 each time. And what about the first term? That's going to be 8. Okay, just a coincidence this time. They're both 8s. They don't have to be the same, and they weren't in the last problem. And Micah, what's that formula we plug into?
Equals A1 plus D parentheses n minus 1.
Plus D parentheses n minus 1. Okay, that's the formula we got from our sheet. And what's A1? A1 is 8. And what's D? Yep, D's also 8. Okay, same thing as last time. What property do we have to use to simplify that? Yep. Okay, what's 8 times n? 8n. And what's 8 times negative 1? Negative 8. And when you combine your like terms, what's positive 8? Take away 8. 0. These cancel out. Positive 8, negative 8. So what's the only thing you're left with? You're just left with 8n. Okay. So now, if I said to you, use that formula to find the 10th term, what number would you plug in for n? If I said use, yeah, you plug in 10. And 8 times 10 would give you how much? 80. So if you wanted to know the 10th term, it would be 80. And I didn't have to figure out the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, or 9th. I just plugged in a 10, and I got 80. And that's how you find it. Okay. Any question on that? All right. So that's the notes on arithmetic sequence. So you guys have an MCAS question. It's just one question this week, but it has four parts. Okay, so you got about 10 minutes, so you can use the time to work on that a little bit, and then tomorrow I'll check the MCAS and we'll work on the IXLs.